So today we're just going to be going over some laws of exponents. So the first one we're going to go over is the multiplication law, which states that a to the power of s times a to the power of t. This is where a is a number that is greater than 0. A to the power of s times a to the power of t is going to be a to the power of s plus t. So the way that works is, say we have like 8 squared times a cubed, which would be a to the power of 5 by this rule. So the way that this works is we have a times a, which is a squared, and then we're going to have that times by a times a times a. Oh. And since they're all multiplication, we can just remove the brackets. So it will be a times a times a times a times a, which is just 5, a multiplied by itself 5 times, which is a to the power of 5. Great. So then we have the multiplication rule, which is that a to the power of s, let me just get a good s there, and then all that to the power of t is going to be equal to a to the power of s times t. Oh, maybe I'll get a lowercase s there. There we go. The way that this one works is that, so say we have a to the 2 times, well, maybe we'll do a to the 3 to the power of 2. So 8 to the 3 is just going to be a times a times a. And then all that squared would just be a times a times a times, with the same thing, a times a times a. So that's all. We can again remove the brackets. And it's all going to be just equal to a to the power of 6, which is equal to a to the power of 3 times 2. Okay. Then we have the rule where a, b, so a, b are both positive numbers, and they have to the power x, they're going to be equal to a to the power of s times a to, or b to the power of s. The way that this works is that, say you have ab squared, you have ab times ab, and since ab is really just a times b, then it's all multiplication. You could order it in any way you would like, so you could really go a times b, which is just a squared times b squared. Next rule is that 1 to the power of s will always be equal to 1. This works because 1 times itself any number of times will always be 1. 1 to the power of 0, as we'll see later, any number to the power of 0 is 1. And then 1 to any negative number would just be 1 over 1 times any number of 1s, which would also just be 1 over 1, which is equal to 1. So any number to the power of a negative number, so any positive number to the power of negative number, is equal to 1 over a to that positive exponent, or equal to 1 over a to the s. So the way that this one works is a bit more complicated. You can simplify, let's get back to white. You can simplify a to the negative s to be equal to a to 0 minus s. And when you have two numbers, when you have this, as we saw with the multiplication rule earlier, instead of a plus sign, you have a negative sign. So instead of multiplying a times a to the 0 times a to the s, instead of that, we'll be dividing a to the 0 by a to the power of s. And since any number to the power of 0 will always equal to 1, then it's always going to be 1 over a to the power of s. And this little equality also works because any 1 to the power of any number will always be 1. So when you have a number like this, and you have any exponent there, you can just put the exponents on both sides, which is going to be always just having the bottom side that matters. Then we'll go into the last rule, which is a to the power of 0, or any number to the power of 0 is always going to be equal to 1. And this is just a known fact in mathematics. And it's just something you need to remember. So we're going to go now into some examples just to try out these powers. So our first example is going to be x squared to the power of 3 times x cubed to the power of 4. So first thing we can do is that we can use the exponent rule to multiply those two. So we're going to have x to the power of 6 and x to the power of 12. And then with that, we can use the addition rule, where it's x to the 6 plus 12, which of course is going to be x to the power of 18. Okay, for number 2, we're going to have 35 x to the 7 y to the 8 over 7 x y squared to the power of 3. So we'll start with the exponents once again. So xy squared to all to the power of 3. You use the power of 3 on both of these factors. So you have x to the power of 3 and y times 2 to the times 3. So it's actually not just y to the power of, or x to the power of 3. It's going to be x1 times 3. So that's just going to be x to the power of 3, and then y to the power of 6. So let's just rewrite the initial question with that new knowledge. 35x7 y to the 8, 7x cubed y to the 6. And now we can just divide. So we can just use common factors to divide each one individually. So we'll have 35 divided by 7, which is 5. X to the 7 over x to the 3, which we briefly went over. It would mean x7 minus 3, which is x to the 4, and y8 over y to the 6, which again would be y8 minus 6, y to the 8 minus 6, which would be y to the y squared. And then we just rewrite our answer, which is going to be 5. Oop. My writing's bad, but not that bad. Y to the x4. So 5 times x to the 4th and times x squared. Final answer. And then we'll just do one more example. Bit tougher, this one. We have 3 times x, y, z, all to the 4th. Then we have that times x to the 5 times y to the 2nd, all divided by 9 times x squared, y squared, z. So we'll start with the exponent to the brackets using our order of operations. So 3xyz to the 4th. We can use our rule where we just add the exponent to each factor individually. So it's going to be 3 to the 4, x to the 4, y to the 4, z to the 4. And just plugging 3 to the 4 into my calculator, which is a little bit embarrassing, but no problem at all. That'll be 81 times x to the 4, y to the 4, z to the 4. Put that back into our initial equation, which will be 81 x to the 4, y to the 4, z to the 4. Oh, there you go. Times x to the 5, y to the squared. Then all over 9 x squared, y squared times z. So up here, we're just gonna bring in simplify common factors. So we have the two x's. It's gonna be x to the 4 times x to the 5, which of course would be x to the 4 plus 5, which is x9. And then we have the two y's, which would be y to the 4th times y to the square, which is going to be y to the 4 plus 2, which will be y to the 6. And then we'll just rewrite that again. Our initial answer, 81 x to the 9, y to the 6. Or sorry, initial equation, not our answer yet. Over 9x squared, y squared, z squared, or just z. And then we're going to just divide common factors or common base factors. So we have the x's, the y's, the z's, and of course just our decimal numbers. So 81 divided by 9 is going to be 9. X to the 9 over x squared is going to be equal to x 9 minus 2, which is x to the 7. We have y to the 6 over y squared, which will just be y 6 minus 2, which will be y to the 4. And then z to the 4th divided by z, which will be z to the 4 minus 1, which will be z to the 3. And we just rewrite our answer to be 9 times x to the 7 times y to the 4th times z to the 3. Final answer.